All right, guys, welcome to another lesson in Science 14 here. Beginning of this topic, we're going to start talking about energy and different components that fall in with it. So the first question I ask you, what is energy? And energy is the ability to do work. And now we're going to also talk about, well, what is work? And, what all else is involved in energy. We'll talk a little bit later about what is work. Just right now, the main definition of energy is the ability to do work. And energy can be divided into two types of groups. First one is kinetic energy, and this is energy due to motion. So anytime that you have something moving, you're going to have kinetic energy. And potential energy is stored energy. So you are standing up top of a ski hill. You're not moving yet. You have a lot of potential energy. Then when you start going down the ski hill, then you're full of kinetic energy because you're moving. And we can look at it here. This picture shows a bunch of different types of energy, specifically broken down into potential right here and kinetic over here. So if we look, first one, we look at elastic. Well, within a tennis ball itself, until you hit the tennis ball, there's stored energy. Then when you hit the tennis ball, the elasticity of the tennis ball will bounce off the tennis racket and start moving and change into kinetic. Nuclear energy, so atoms contain a lot of energy when the bonds are broken or when they're fused together. They start giving off more, so there's a lot of stored energy there. Light bulbs, okay? A light bulb itself doesn't really do anything. You flick the switch and connect the current, that electrical energy is going to transfer to the light bulb, so that before you do that, though, there's a lot of potential energy stored there. Gravitational, we're all pulled or held down to this earth by gravity. We stand up on top of a chair. We go to step off. We're moving. We're kinetic. But while we're standing up there, we're full of potential because we're always going to be pulled down. So that's a gravitational potential energy. And just like chemical, any sort of chemical reaction where you're combining compounds or breaking apart compounds or elements, there's chemical energy stored within those bonds. Next thing we talk about kinetic. And again, kinetic is anything we move. So just like we said before, over here with the electrical energy of for potential, like the light bulb, once you actually connect that current, you're going to have movement of electricity. Okay, light is always moving, and that's a stored form of energy. Wind, thermal energy is always moving. You're going to have thermal energy moving from one body to another through the types of conduction, convection, or radiation. Sound energy is moving because we can hear it. So there's just some examples of the different types of energies. Specifically, though, again, thinking about it, you have potential, which is stored, kinetic, which is moving. So what is work? So work is a force times distance. So if we just look down here, work equals force times distance. Now if you look at the triangle method, when you're trying to figure out work, you can see that work equals force times distance because the F and the D are beside each other. If you had to figure out force would equal work divided by distance because the W is over the D in this instance. Or if you had to go what is distance and you had work and force values, you know that it was work divided by force. So that's just a simple little triangle method to figure out some calculations. You're going to need that when you're doing your assessments. So again, a force is a push or pull. Work is done when a force moves an object over a distance. And we're going to talk about some conditions that go into work. So you need to have a force and you need to have some movement. Combining them together again, force and work, combining force and distance together, you're going to have work. Now work is recorded in various ways. First way you can do it, you can have a Newton meter, so a Newton times a meter, and is the work when 1 Newton of force is used for a distance of 1 meter. So again, you have 1 Newton of force and you have 1 meter. That's a Newton meter. That's a way to record work. That's the units. Now the other way is a joule. That's represented by a big J and is a standard way of reporting work, and that equals a Newton meter. So writing a joule and a Newton meter is the same thing, but just two different ways to write the units for work. Now conditions for work. So there are 3 conditions that are very important. First one, there must be a force. So you're sitting there listening to me right now, not moving, even though you're like, man, you know, if your teacher asks you and you can say, man, I did a lot of work today. If you're not actually applying a force to anything, technically you didn't do any work. So the first one, there must be a force. Second thing for there to be work, there must be a distance traveled. So you're a football player, you're a football player is a great example, you're a lineman. You go and you start pushing against another lineman. Neither of you move. Even though you're pushing as hard as you can, there was no distance traveled, therefore you're not doing any work. And then the last one brings number 1 and 2 together. The force and the distance traveled have to move in the same direction. So you are a lineman again, you're pushing against another lineman, so you're applying a force, and you start pushing that lineman backwards, then you are doing work. Another great example that gets people confused, I'm standing in the room, I pick up a backpack, and then I start walking across the floor. I actually pick the backpack up from the top though, so I pick the backpack going up in a vertical motion, but then I start walking in a horizontal motion. Therefore, I'm actually not doing work because they're not in the force and the distance I'm moving is not in the same direction. If I start pushing the backpack across the floor in a horizontal direction, then I am doing work. So there's just a little bit about energy. Again, energy is the ability to do work, and now you know what work is also.